In this video, we will talk about conditional statements. These are the statements of the form if P then Q. Symbolically, we can write it as P arrow Q, which is read as P implies Q. Instead of using this arrow, you will often find people using this arrow. That means the same thing as P implies Q. Here, P is called hypothesis and Q is called conclusion. Next, we will look at truth table for a conditional statement. So for the truth table, we'll have P, Q, then P implies Q. So for the truth table, we will consider all the possible combinations of truth values of P and Q, and then determine the truth values for P implies Q. So we can have P true, Q true. We can have P true, Q false. We can have P false, Q true. And we can have P false, Q false. So these are the possible combinations of all the truth values of P and Q. Now P implies Q. If P is true, Q is true, then P implies Q will be true. A true statement implies a true statement. When P is true, Q is false. P implies Q will be false. A true statement cannot imply a false statement. When P is false and when Q is true, P implies Q will be true. So if the hypothesis P is false to start with, if the conclusion is true, then the conditional will be true. The last one, if P is false, Q is false, then P implies Q will be true. Again here, if the hypothesis to start with is false, then no matter what the conclusion is, whether it's true or false, the conditional will be true. So when the hypothesis is false, here we say true by default or vacuously true. Or true by default. Let's look at a couple of examples for vacuously true statements. I can say if sun rises in the west, then it snows in summer. This is a true statement. The whole conditional is a true conditional because the hypothesis part, if sun rises in the west, is false. So here we have false implies false. If part is false, then part is false separately. So we have false implies false, but the whole conditional is true. Similarly, as another example, I can say if sun rises in the west, again, then it snows in winter. So in this case, the hypothesis is false and conclusion is true. So we are looking at false implies true. And from the truth table, we can see this statement is also true. So this statement is true and this statement is true. So they are vacuously true or true by default. So anytime you start the hypothesis part as a false statement, then the conditional is going to be true. As another example, if 3 is an even number, then everyone in this course gets an A. Gets an A. The conclusion part in this case may not be true or may be true depending on which particular class we are looking at. But the hypothesis part is definitely false. So since the hypothesis part is false, we have this situation here. So this conditional, if 3 is an even number, then everyone in this course gets an A, is a true conditional, a true statement. Now let's construct a truth table for statements involving conditionals. So let's look at this example. Here we have P and not Q implies P and Q. So on our table, we need P, we need Q, and looks like we have not Q over here. So we'll need not Q. We'll need P and not Q, and we'll need P and Q. And finally, we'll need P and not Q implies P and Q. Now we will put down all the possible combinations of truth values of P and Q. So we can have P true, true, false, false. And we can put true, false, true, false. This way we get all the possible combinations of truth values of P and Q. Next we have not Q. So we can just negate this column. We have false, true, false, true. Next we have P and not Q. So we look at this one and that one combined by and to get this column. True and false is false. True and true is true. False and false is false. And false and true is false. Next we have P and Q. So we'll be looking at these two columns combined by and. True and true is true. True and false is false. False and true is false. And false is false. So we got these truth values for P and Q. And now finally, we are ready to do the truth values for the given statement. So we have P and not Q, which is this column over here, implies this column, P and Q. So we have false implies true. This is true by default since the hypothesis part is false. True implies false would be false because a true statement cannot imply a false statement. False implies false is true by default, and false implies false is again true by default. So these are the truth values for this given conditional statement. Okay, now a few examples here where we want to write these statements in symbolic form. The first one says if this month is January, then the next month is February. So we can let this statement, this part, this month is January to be J, and this statement, the next month is February to be F, then it becomes J implies F. Similarly here, the next one, let's call S to be it snows. And let's call R to be it rains. Then we have S implies not R because it says it does not rain. Let's look at the next one now. If X is even, then X is divisible by 2. This one is also quite straightforward. I can just let this to be E, the statement that X is divisible by 2 to be T. Then we have E implies T. The next one we have if N is prime, then N is odd or N is 2. In this case, I can let the statement N is prime to be P I can denote the statement n is odd by O, and I can denote the statement n is 2 by T. Then we have P implies O or T. So O or T, I can write like that. The last one, if n is divisible by 2 and n is divisible by 3, then n is divisible by 6. So we can denote this part by T. We can denote this part by H, and we can denote this part by S. So we have T and H implies S. So this is the fifth statement in symbolic form. There are more ways to write a conditional. These are some of them. P implies Q, or if P then Q can be written as P only if Q. For example, the first statement says if this month is January, then the next month is February. So using this format, we can say this month is January only if the next month is February. The next month is February. The same idea with the others. For example, let's do one more for this format. If we look at number 3, I can say X is even only if X is divisible by 2, and so on. So you can try the other ones. Now let's look at the next format. This one, Q if P. So in this case, we write the conclusion part first. For example, if we look at the second statement in the example, we have it does not rain if it snows. Because given here we have P implies Q. So I can say Q part first, Q if P. Let's look at one more. Let's look at the fourth statement for this format. We have N is odd or N is 2 if N is prime. The same idea again, we write the conclusion part first. We write Q first, Q if P, because here we have P here and then implies Q. The next way to write a conditional is to use whenever. So if we have if P then Q, we can write that as Q whenever P. So let's look at one example with this one. If you look at the second statement, we can say it does not rain whenever it snows. So again, here we write the conclusion part first. Okay, if we look at the fifth one as another example, we can say N is divisible by 6 whenever N is divisible by 2 and N is divisible by 3. The next format is Q follows from P. Let's look at some examples with this format. If we look at the first statement, again, here we write the conclusion part first. The conclusion part is that the next month is February. So we can say something like this. We may have to rephrase a little bit. The next month being February follows from this month being January. Or you can write it slightly differently so that it makes more sense. Maybe we can say something like the fact that the next month is February follows from the fact that this month is January. Maybe I can write down what I just said. I can say the fact that the next month is January. The next month is February. Follows from the fact that this month is January. Let's look at one more example with this format. Then we can look at number 3. If x is even, then x is divisible by 2. So I can say the fact that x is divisible by 2 follows from the fact that x is even. Okay, and you can try the other 3 statements. Let's look at the next one now. P is sufficient for Q. So this is another format for writing the conditional if P then Q. So for example, let's look at the second statement here. We can say that it snows is sufficient for that it does not rain. It may sound a little bit awkward because we don't say this statement using the word sufficient in general when we talk in our daily life. Let's look at number 4, that n is prime is sufficient for n being odd or 2. And again, you can write it in different ways using the word sufficient. Now let's look at the next format we have. A sufficient condition for Q is P. So let's try using this format for some of these examples. Let's look at number 3. So we can say a sufficient condition for P, for Q, for X being divisible by 2, that's our Q, is that x is even. That x is even. Now let's look at another format. We have Q is necessary for P. So let's look at the first statement as example. Our Q is the next month is February. So I can say the next month being February is necessary for P is necessary for this month being January. Let's look at one more example with this one. Let's look at the fourth statement. So again, we have Q is necessary for P. Our Q is this part. N is odd or N is 2. I can say N being odd or 2 is necessary for N being prime. For N being prime. And you can try the other three statements also. Now the last format here is a necessary condition for P is Q. Let's try some examples with this one. Let's try the second one. So I'm going to start just like in the format, a necessary condition for P. Our P is it snows. For I can write it in a little different way, saying for it to snow is that it does not rain. Here for it snows, I wrote it in a little different way, for it to snow, so that it makes a little bit more sense. Let's look at one more example. I'm going to try number 3, a necessary condition for P. Our P is x is even. For x being even is that x is divisible by 2. So these are some of the ways of writing a conditional. Now let's look at a few more examples where we write these given conditionals in different formats in symbolic form. The first one is this month is January only if the next month is February. So from the examples we just did, so if I denote this statement by J and this statement by F, then we simply have J implies F. The next one, it snows whenever it does not rain. So in this case, we have this part implying this part. So basically, if I let this by S and this by R, or I could say not R if we let R to be it rains. So S is it snows and R is it does not rain. Then we have not R implies S. The next example, a sufficient condition for X to be even is that X is divisible by 2. In this case, again, we need to figure out which one implies which one. In this case, this part implies this part. So if I denote this by T and this by E, then we have T implies E. The next example, a necessary condition for n to be prime is that n is odd or n is 2. Again, in this case, we want to figure out which part implies which part. Since these two are necessary for this one, we have this whole thing, n is odd or n is 2 implies n is prime. So if I let this by P, this by O, and this by T, then I can say O or T implies P. Now the last example here, that n is divisible by 2 and n is divisible by 3 follows from that n is divisible by 6. In this case, we have this implying these two statements. So if I denote the first one by T, this one by H, and this one by S, then we have S implies T and H. Maybe I can use parentheses here and here also.